Welcome back to another presentation up to the time. Today we will be looking at windows. In the first half, we will look at window types. As we can see here, we will look at window symbols also. We will look at the window details. We will look at the parts of a window. And then lastly, we will draw a window isometric. And then we will stop, review what we have done, and then we will go over to the door. So let's start here. There are several types of windows. And first thing, probably ask yourself, what is a window? So I'll go to Google and let's put that in. What is a window? And you will see a window, an opening in the wall or roof of a building or vehicle that is fitted with glass or other transparent material in a frame to admit light or air and allow people to see out. So this is what a window is, for those of you who might not know what a window is. Anyway, let's go back now to the presentation. So there are various types of windows. Yes, there's side hung window, where it opens from the side. The access, there's top hung, where the opening is from the top. Bottom hung, where the opening is from the bottom. Fixed light means that no air enters through this window opening, only light. It does not open, it's just fixed. So it's a fixed glass there, right? Fixed light. Then there's a vertical pivot. Horizontal pivot is similar, only thing that the pivot stick is on a horizontal, is set up horizontally, whereas this one is set up vertically here, and this one is set up horizontally. Then there's a double hung. These are sash windows where the window panel goes up or it can come down. And when this one is going up, that means then that all in here is where you will get your wind, and this one will be closed. Sometimes these things can move simultaneously, so both can be open, where this one can be slightly down and this one can be slightly up. I will show you some examples shortly of these. Horizontal sliding windows, where the openings, the arrows direct where this opening goes, and so forth. Again, I'll show you these shortly. Then there is a double casement window. Where's the opening? The window is split in half, and the opening, this is one opening right here, one half of the window. Then this is the other half of the window that can open. So what can happen is you can have one half completely open and the other half completely closed, and that's how that window operates. Then there's the louvered windows. Okay, so let's look at these examples now. So just now, let's start with the louvered. This is what a louvered window looks like, and let's go back to the AutoCAD. So that's a louvered window here. As we can see, the louver blades, and there are 3 louvers. And over here in the example, there are also 3 louvers. All right, so that's a louver window, nothing too hard. This one here is the double casement window that I've just been explaining. Let me get my my pointer so that I can show you. So this is an opening, like similar like here. So it has 2 openings, 1, 2, and this has 2 openings, 1, 2, right? So that's it there. Yeah. Let's move on to another type. So what do we have here now? Then we have the double hung and the single hung. So let's go back here to this one, this double hung, and let me explain this now. Let me go get my pointer. Okay. So this window can open in from both the top panel and the bottom panel can open. So this is the panel here that I'm referring to, and this can go all the way up to the top here, and then this one can come all the way down to the bottom. Both of them can open at the same time. and that is how wind comes into the window there. So wind would be coming through here, right? This is where the wind would be coming through. I should probably do the arrows for the wind in blue so that you guys will better understand what's going on. So this is where the wind will come through, and the wind will also come through here in the double hung. Both sides can open. That's the advantage of a double hung. Now in a single hung, this up here is fixed. The top one is fixed. So I'm going to highlight that in red and let you see that this one here doesn't move. Yeah, that doesn't move. It's only the bottom area that moves. So I'm going to put this in blues to let you know this is where the wind comes in. The wind comes in here at the bottom, right? So this is the difference between a single hung and a top and a double hung. You can't tell the difference by looking at them. Only when you go inside and you try to operate them, then you can tell the difference. But they look identical on the outside. Okay. Let's move on. And this again, this is a hung window. Can't tell if it's a double hung or a single hung. But when we look here, it looks like this could be a double hung because both of these look operable, both of these tracks. So let's see what else we have here. Okay, then we have this now. Let's look at these. So we've finished with the double hung, and we now have a horizontal pivot window. And right away, we can see that we have a pivot window here. I got a horizontal pivot, right? Pivot horizontal, and then there's pivot vertical. So we can have a look here at these and get an idea of how these work. Let me bring up my arrow and try to explain this. These are pinned here at these points, whereas in the horizontal window, these are pinned here at the side, and in the vertical pivot window, they're pinned at the top and the bottom. So let me just draw a line and show you. This is the pin point, and on this is the pin point. All right. So how does this work then? Once they're pinned there at those points, so I can just put in like a little pin there, there, and there. That means then that these can pivot, and that is what creates the pivoting, rotation, and movement. Once they're pinned there, they can pivot, and that means they can open to the left and open to the right at the same time. So air comes through here and air goes through there simultaneously once these are open. And this is called the vertical pivot window. Some books call it vertical pivot. Some texts refer to it as pivot vertical. I like vertical pivot. I think it sounds easier to understand. And let's go over now to the horizontal pivot or the pivot horizontal window. These are pinned here at the side. So this is where these are pinned. And that will be here, and there. And that means the wind would come in at the top and the bottom. So the wind will come in there and the wind will come in here. Also the wind will come in there and the wind will come in there. So that's how those work. And so those are the two pivot windows explained. Now we can see here there is a top hung and a side hung, right? And we already have a side hung here and we already have a top hung. So let us explain this. What does the hung really mean? The side hung and top hung. The hung is where the window operates from. So this one operates from the side, right? So that is what holds the window to the frame. It holds the window there to the frame at the side, and this holds the window to the frame at the top, right here. So this is where the window opens and closes. If that wasn't there, the whole window would drop out. So that is the point that the window is fixed to the frame, right? So at the side, you will call it a side hung. And when it's at the top, you will call it a top hung. When it's at the bottom, you will call it a bottom hung. And that is how these windows operate. So you push these windows out and pull them back in. Let me show you how wind comes through these. So the wind will come through here. And for this, the wind will come through the sides, right? Just like that. So those are your hungs, and these are your pivot windows here. Let's see what else we have here. A fixed light, like I mentioned, is just a fixed glass. Nothing goes through there except light. No wind can go through there. So as an example of a fixed light window would be in an aeroplane. In an aeroplane, you can just look through the windows, but you do not actually feel the wind coming in, right? So that will be a fixed light window. That's a good example there. Let's see, what else do we have here? We have the sliding windows. I didn't go through the sliding windows. Let's look for this horizontal sliding and see how we can explain that. Yeah, I see it right here. I think I have another example, so just let me look quickly for this horizontal sliding. Yeah, I have an example here. I think I have a better one. Right, this one here, horizontal sliding. Now the arrow indicates the direction in which the window slides. So this window slides on this track. So this point right here will go all the way to here. Yeah. And when that gets there, as it slides closer to the corner in the direction of the arrow, this allows a bigger opening for wind to pass through. So that's the opening there that the wind will pass through. And you can show the arrows. There the wind comes in. And the red arrows indicate the direction in which the window slides. That will represent it is fully open. So when it gets here, that means it's fully open, right? Okay. So let us clear. So that's the horizontal sliding. And let me see, what else do we have here? We went through the fixed light, the bottom hung, top hung, side hung, vertical and horizontal pivot, the double hung, the horizontal sliding, the louver, and the double casement windows. These are the general types that we get. I could just look at them here. There's one more type that is here that wasn't mentioned. There is the jealousy. These are louvers. When you hear the word jealousy, you should think of louvers, jealousy windows. Let us probably go and look now to see if we can find a jealousy window on the internet so I can give you a better understanding of this window. So go here, J-A-L-O-U-S-I-E, jealousy. Now, the jealousy windows that we are seeing here, these louvers are operable. There are some jealousy windows. So let me just re-explain that there are some jealousy windows that when they come, the louvers are fixed like this, right? Usually they're shutters. Some can be shutters on the outside to protect the window from storms and stuff. So things blowing around, and if any flying objects hit, they would actually hit the outside of this window and they would actually not get inside. Some jealousy windows, these are some here. The glass louvers are operable, but in most cases, what can we take away from here? Jealousy windows are windows that have louvers. Some they are fixed louvers, some they are operable louvers. Some the louvers are made out of glass, and some the louvers are not glass, they are timber. Right? So that is one thing we can take from this looking around here. Again, look here, this one, the louvers are closed. This one here, the louvers are open. And okay, sometimes they can be out of metal too. They don't always have to be I like this one here. I like the look of this. You don't have to always get them in timber or get them in glass. You can get them in metal also. All right. So these are the jealousy louvers. This is the louver system here. And you can show then the operable lever here at the side. All right. So that means this one is operable. But again, this one does not say jealousy. So this is just a typical louver. It looks like. All right. So that's it for these types of windows. Let's get back over here. So those are the window types. That's the first thing. That's the first kind of part of our presentation finished. Let us now look at the window symbols. So I'm just going to maximize here and let us look at these window symbols. Now, when we think of symbols, we think of how to represent these windows in plan and how to represent these windows in elevation and perhaps section. We will look at the section later on. But when you're drawing a house, you need to or any building, we need to show how these windows will look in plan when a person is reading the drawing, or when they're about to build the house, they need to allocate a space for a window. And these are represented by specific symbols. And let's have a look here at these. So on plan, pretty much the plan symbol for window is the same despite what a type of window it might be. So you can have a fixed light window over here, and you can have the same symbol as a louvered window on plan. So generally speaking, all the plan symbols for a window are the same. Generally speaking, they don't change. You cannot look at a symbol on plan when reading a window and tell the type of window that it's going to be. You would have to look at the elevation to determine that, because all the plan symbols are pretty much the same. The only variation, as I'm going to show you here, is when we have a side casement window where it opens, it shows you the opening. Yeah, this is what this is doing. It's showing you the opening here of how the window opens. And let us go down to another change here. Also at the bottom, you will have a double casement. And again, it shows you where the window opens, it shows you here, the window is opening from the left. And again, the window is also opening from the right. That's a double casement. Other than that, you would not be able to see a difference in the plan symbols when we are looking to identify the windows. So just look at the typical one here, and this is what a typical plan symbol would look like when representing a window. This is it here. I've just highlighted it. And we're going to draw one of these now, because I think it's very important that each student knows how to draw one. So I'm going to draw this, and then I'm going to put it into the template, or I'm going to put it into the block menu so that we can always retrieve it from there. And I'm going to show you how to retrieve it after I've drawn it. So let me just stop here for a moment and let us draw this. So say you have a house and you need to put some windows into this house. So let's make this more interesting. Let's create a rectangle here. Yep. And then let me just offset in here 150. Say 150 is the thickness of my walls. Okay, that's 150. What's the thickness here? Let me measure of these. That's 431. So obviously that has been increased. That has been increased for this presentation. But let's just say we're working here with these walls, and this is 150 thick, and that will be the size of a wall. Let me put a line through there. Measure DI. Measure that point there to there. Okay, good. So that's 150. And what I'm going to do is copy this line down. So this determines, hey, say I want my window here. So this is where I'm going to place my window, right? So right here is where I want to put my window, because I want to have a window right here on this wall too. So I can bring some light and we can bring some air in here. How am I going to do this? Well, the first thing I'm going to do is I'm going to go over to my window layer, window and doors. Yeah, I have a specific layer for windows and doors. And then I'm going to create a rectangle. So the first thing is REC, rectangle. And I know this is the distance of my window, and look, boom, that is a rectangle there, right? All right. I'm going to move this outside so you guys can see as I'm drawing. So I'm just going to place it here. So I've created a rectangle, which is the actual distance, the width of my window. Now, what else do we need to do? We need to put in some frames. Windows have frames at the side, right? Again, so we need to put in a frame here, and we need to put in a frame here. That's the next thing that I'm going to be doing, all right? So how are we going to do that? The frame thickness is 50 by 150. So seeing that we already have our 150, we already have our 150 from here to there, which is our 150. We just need to offset out here 50 and out there 50, all right? So let me just do that. That's the strategy. So, but before we do that, this is actually a block, which is a rectangle. I need to explode that. EXPL, that's the command, explode, touch it, and it's now been, it should be exploded. Right, now these are all single lines. So that means now that I can offset the size 50 millimeters each, and it wouldn't offset the whole thing because it's no longer a group. All right, so I've offsetted my sides, I got my frame, and now I need to find a center line, and this is my center line there. All right, so that's my center line, but at the center line now, I need to create the thickness for my glass. What's the thickness that I'm going to use for my glass? I'm going to use 20. So I'm going to offset 10 to one side and 10 to the other side. Let's get 10, 10. So there's my window. So that's my window with a frame. So let me just label this so that you guys would generally understand what happened. This is the frame, and that there is the glass, right? So that there is frame, and that there is glass, right? So that's it. That's your window, that's your frame, and that's your glass, and that's how we create a window. So now that that is finished, what am I going to do? I'm going to make this a block by selecting the whole thing, blue grab or green grab. If your green grab come from this side, and then type the letters BL, which brings up the block menu, hit enter, and now I'm going to put this in as a window. Now, if I knew the size, actually, let us look for the sides here, the sides, as in the length of the window. So DI to distance, grab here, come here, and the distance is, probably you guys at home wondering where am I looking to get my distance. I look down in there and I get my distance whenever I DI. So let us do this again, DI for distance. And you grab here to there, and then I look down in there. Aha, you see the distance is 2235, 2235, 2235. All right. Now what am I going to do? I'm going to grab this and then hit BL. And why was that distance important? Because in the description of the window, I can place the distance so that I would know exactly what type of window this is. So I can put here window 2235 and I can leave that there, or I can come here in my description and I can put 2235 size. You have more wording that can be placed into the description if you choose to, right? So now that's the window there. So now I can slot this into place by moving this from this corner and pulling it right down to here. And then remove these lines, which were just reference points. So now my window is in place, and that's the window. What does that mean? That means that breeze can come through here. Let me use the blue arrow to breeze, not green, a blue arrow. That means breeze can come through there and breeze can come in and go out, right? Yeah, just like that. That is what you call natural circulation of the air, right? So we allow it to happen. That's our window there. And that's a typical window symbol that is used to show what to show where a window will be located on a plan, and just to show the size of the window opening. That's all. Now we will have to look at this same view in elevation to determine the style window. So now that that is finished, let's look down here and look at the different styles that you can see from the elevation and what they look like. So let's go down. This is the side hung casement. And when we look at this window, we can see what it looks like on the outside. We can see the frame. We can also see the glass, but we can see these two red lines here. What do they represent? Now, remember when I was explaining to you guys earlier, so I'm just going to draw a simple rough diagram. Yeah, so this is a diagram here of the window opening or window frame. Let me just come here to make this more interesting. Yeah, okay, so that's a window frame there. Now, I was explaining to you guys earlier that on this side, you can actually tell that the window is opening here, right? Right here, because it's a side hung. But there are some clues that help us to determine that it's opening on that side. It could have also opened on this side. How do we know which side it opens? Now, these two red lines here always point in the direction to where the window is opening, right? They always point in the direction to where the window is opening. But you might not be able to see it. That's pointing there. To you, that looks like just this. How does that indicate that the window is opening on the left side? So these indicate left side opening or left side hung, where it is stuck to the actual frame, left side hung. So I'll put there. How does this tell us? Well, if we really look at this carefully, this is in the shape of an arrow. Yeah. And if you were to fill in here, if we were to just fill in here with some sort of a solid fill, that would be an arrow pointing to this line, right? Like that. So that is basically telling us that the side hung casement window is operable from the left side. If it were on the right side, you would see the arrow pointing to the right side. So one thing you can look at is always look to see where, in essence, always look to see where these are pointing to. They're pointing there to that. That means the window is opening from that side. So if I were to do it like this, probably it might make more sense to you guys that those are arrows or lines indicating where the window opens from. And this also is a symbol that you see when you're showing where the doors open from, where the hinge of the door is located. You would also use the same and similar technique, right? So this is a side hung casement window. We can see it opens. Sorry, you can see that it is pivoting or it is fastened to the window on the left side. This one is fastened to the window on the top up here in this area. Let me just, yeah, in this area, that's where it is connected to the window. And that one is a top hung casement, bottom hung. You can see where the arrow is. Fixed light, that doesn't need any due to the fact that this is narrow opening. Pivot window, it doesn't need any because these pivot at the top, they have their pins. So you have a pin here and you have a pin there, and this opens. Again, there isn't any way to indicate where the pins are. You just have to read the word vertical. You know that vertical deals with things going from top to bottom, right? You just have to know that is one of the things about this type of window. Horizontal pivot, again, you have to know the word horizontal deals with things going from left to right. It comes from the word horizon. And I always like to tell my students, the horizon is where the sun here. So you can imagine the sun going down below the the horizon line, you know, when it's sunset, it goes like whoops. So this is the horizon. Always remember that long line in which the sun goes over or goes under the line, however you want to call it. That is how I remember the word horizontal, going back to the root word horizon. So once I remember horizontal, I then know the opposite is vertical, right, which is up and down. Double hung, we wouldn't have the window indicators to show. We would just have these arrows which show where these windows open, up and down, vertical openings, and then these are again horizontal sliding, and these slide from left to right. Let's see, what do we have? We have another one here which shows the opening, right? So this is a double casement. That means this window opens from both the left and the right. The window is, you can say, it's divided in two, and the opening points are left and right. So again, with the information that we know, we can look here and we can see this. These are the points that literally don't move. They just, you push against the window and those areas don't move. But if you push against the window, it opens. Like here, it opens out. But these are the fixed points. Yeah, these are the fixed points which represent here and here. And again, how do we know this? The arrows always point here. So you can see these lines as an arrow, or you can see the big triangle as an arrow. And when I say the big triangle, I mean this. You can see this as an arrow pointing in that direction. That's pointing in the right hand, and this one is pointing in the left hand direction, if you can visualize triangles pointing to where you need to observe. And again, the louvered windows, you can see the louvered where the hinge from that side there, and then they open up. So that point there is fixed, and then the rest just opens to allow the wind to enter. That is basically it for the windows and the window styles. No, sorry, the window symbols. Again, we place this into a block, and I didn't show you guys where to find these blocks. So let's just go back over there for a second. So if I delete this here and I wanted to find it, I can come up here to the word insert, click, go insert. Try to drag out this, and look, this is my window 2235. So I grab it and I put it there. Let's see, did it come in there? Now, things have a tendency of, when I bring them in, they go all the way to the far right of the screen. This is something that I've noticed. I need to fix this, and I will probably fix this so that next time I go into my block menu, I wouldn't have to do all this foolishness. I don't know why. Everything in AutoCAD is a setting. So this is the window here that we just created, which is what is my real intention, to show you where to retrieve the window from. Again, you'll find this in the block insert menu, and it's right here. Be careful, most of my items coming out of the menu, you have to go to the top right hand corner where you find the compass symbol, and you would find it. So like example, if I bring in this window and it tells me where do I want to put it, and I put it here, well, that one is there. Then the next thing is you need to scale this up. That's not generally a problem for me, but locating it is usually a problem. Sometimes it comes there, sometimes it comes over in the north, over by the north symbol. So that's a window. And now let's look at windows in elevation. Now, how am I going to draw this in an elevation? So which one of these should I draw in elevation? So I just draw this top hung. So I'm going to copy it over here. And the first thing, okay, So imagine we want to draw this window, which is to represent that opening, right? So I just move this to the side. So the first thing is I'm going to take the distance. Okay, that come down here. Okay, distance. And I'm going to use the height of this window to give me everything that I need to know, right? Cool. So this is the frame that we're working with. I'm just going to trim. All right, so that is the outer shape. Now let's put a frame on here. I'm going to offset in 50. Okay, how do I want to treat this frame? I see how they've treated it. So I'm going to trim here at the top, trim out here, trim out here. What am I doing is I'm actually creating the frame for the window. So I've not yet created the window. I'm just creating the frame for the window. So the frame is designed. Good. So that's how they have designed their frame. And now I need to actually start looking at putting the window together. So this is a hung window, and they have theirs about here. So I'll probably put mine at about half. Yeah, so I can represent. So below is going to be open. Now I need to get another frame on the inside here. So let me just grab the distance from here. So whenever I want to grab a distance from anything, I press DI, and this brings up the distance menu, a tape measure. So I just grab this distance, and that distance is approximately 25. So I know I can offset around here 25, and I'm good. All to offset 25, 25, 25, and then offset that down 25. Let me fill it. Yeah, fill it. So I join these together. I have to fill it, by the way. Click, click. All right. So that's it. But now let's deal with the top bit. What's happening at the top? Now, this has an outer frame that we need to observe. This is what I mean, an outer frame here. So we're gonna put this in. Yeah, we're gonna put that in. Then we're gonna put in this bit here. Yeah. And all these parts of the window will be discussed later on in this presentation. But for right now, it's just about drawing so that you guys can get a feel of how to draw a window. All right, so we're gonna put in those 2 bits. So let us now clear. Again, what are my sizes? DI to grab my distance. That's about 80. I'll call it 80. It says here 81, but I don't like numbers like that, so we'll go with 80. Yeah, let's go with 80. And what's the inner one? No, so once I remember both these numbers, 80 and 28. All right. So offset 80 in here. And just fill it. $28 now. Hey, if you guys want to use 25, that's cool with me. Hey, reality is no one's gonna come wrong really and measure, argue. Well, I certainly wouldn't. Once it looks like a window and the proportions are right, well, it's a window. Just extend these up and extend that down. Cool. Yeah, so we pretty much got our window there, but again, we need to represent where is the hung, the top or the bottom. Well, it's at the top, so I need to pull this to there, to half, and pull that down to there. And I'm going to put these in dash lines because they're really supposed to be in dash lines or hidden lines. Why are they supposed to be in hidden lines or dash lines? Well, they represent the fact that you're not going to see them when you look at the window. You know, they're not visible. They're not part of the window. They just represent, they just indicate. These are just indicator lines, which indicate how the window operates. So that there is your window, and this window can then be, yeah, it can compare, so it will fit in there. And then when I've created this window now, I would then now call it up as a block. So I will grab everything, BL, enter, and that's there. So this now becomes window elevation. Elevation. And I remember the size was 2235. We can put here elevation size 2235. If I can remember correctly. Let me save that. Now, if you want to retrieve this, go to insert, and look, it's right here. So you get the plan and you get the elevation of the same window. How amazing, huh? Delete these now because we no longer need them. Or I could just leave them there so they represent what has been done throughout this presentation. So now we have covered the window types and we have covered the window symbols, join them in plan, join them in elevation, saving your symbols, and then retrieving your symbols. All right, so now what's next now? What's next? We need to look at the parts of a window. Very, very important. If you're given a window, you need to know the parts of the window. So we're gonna, let's go back to here, split these screens into two. Yeah, so here's another one. And let's start with, this is a sash window, or what we would call a hung window, right? It looks like, can't tell if it's a double hung or single hung, but let's just assume that it's a double hung. So both these windows move. So let's look here and see what we can see and compare what I have, right? So let's zoom into this one. And what these two X's here mean, those are just my points that have grown extremely large. So I press RE to regen my screen so as to hide these points. All right, or you can press DDP and that carries you to P type, and I can put it on to a speck of dust. That means it will never be shown again. Useful to know. Sometimes it actually confuses you while you're navigating around the drawing. All right, so let's get back to what we really came here to do. Came here to list the parts of the window. So let's start at the bottom. And we have here the sash. Right. Sash. This is the sash part of the window. Then there's the lug, which is right here. The lug of the window. You guys would have probably heard the word sill. Be careful with this word sill. We here in the English, we here in Barbados, we spell it using the English standard, using the English way of spelling it, S-I-L-L. I've seen this same word spelled C-I-L-L, and that it also is called sill. That's how the Americans spell it. So you need to be careful when writing it. Observe the two spellings. Okay. So that's the sill, and that's where it is here. And all down here would be the sill that I'm now highlighting. Yeah, that's the sill. Now let us move on now. There is something called the mounting of the window, which basically represent these bars here. So I'm going to use a different color. Probably use red to represent the mounting. That, and these bars there, those are those will be mounting of the window. And then there is a blind stop. What does, when you hear the word blind stop, what do we think of? Well, this stops the window as it is traveling up and down, as it is going up and down the track. And the blind stop is right here, right in there, and it is somewhere back here on elevation. That's where the blind stop is. That actually stops the window as it's traveling up and down. You know, when it gets into place, it can't go any further. It's like a security way so that the window doesn't run off the track. That's how I see it. Brick mold, right? This is a nice little artist expression right here, which gives the window some character. It could be right here. You can find it right there at the top. Some people shape it with a nice curve formation, as you can see, which gives the window extra character there. One thing else, so I'm just going to clear this off. Let's go again. There's a meeting rail. Right here, it's the meeting rail. Right there. Right there. Right. Actually, I'm going to erase this and bring this in. Yeah, you guys should be able to see this better now as I'm explaining. Right. So this is the meeting rail again. Meeting rail over here. Again, we got the sill. Nice sill here. And let me address something. Why is the sill slope like this? Why is this? I'm just going to go on this color. Why is this like that? Right? Why does this slope happen? Why is the shape of the sill like? Why is this the general shape of the sill? Why? The sill is set up like this so that water would flow and run off, right? That is set up so that water will come there, flow, and then it will run off, right? And it will go along about its business. When rainwater comes in, of course, you know it's a window, so it's going to get rain coming against here, and that is going to be the natural path of the water to get the water away from the window. So that's why the sill is shaped like that. And you can realize that the sill is different to the head, right? Because at the top, you do not get that slant. So that is something to observe there when you're designing your windows and when you're drawing them. Okay. We're down here, then there's the sash bottom rail. So you get a sash bottom and you get a sash top, right? And then this is the word sash bottom rail. Then you get the sash top rail there. So before we finish, before we go on to something else, just to recap, we have the sash, we have the lug, we have the sill, the meeting rail, the muntin, the blind stop, and the brick mold. All right, those are the general parts of a timber window. Okay, so that is, I would have used this, but this isn't as clear as the other one. I'll just leave it here so that you can observe this perspective. All right. So that's the end of parts of a window there. I encourage students to draw these and label them. Know these parts. 1, 2, 3, 4, 5, 6, 7. These 7 parts at least, you should know them. Try to know them. Try to draw a window and label them, then go back to your drawing and check to see if you have everything right. And also give yourself a grade for drawing and labeling. Give yourself a grade for how well it's drawn, and give yourself a grade of how many parts you can remember. And also give yourself a grade. Have I listed my things neatly? Meaning, do I have a margin here where I can say, hey, all of my work is presented well, doesn't go past this point. What about on this side? Did I organize my text onto the sheet properly? So you give yourself
So there's 3 ways to give yourself marks. Give yourself a mark for your presentation. Give yourself a mark for how well you've drawn the actual window, and give yourself a mark for how much I can remember the parts of the window and I can list them. Once you do that, then you know pretty much that I have this covered. I'm secured in this area. All right. So let's move on now. So now we're going to move on to the section of a window. What happens when we split a window, when we cut through a window? So I'm just going here. Now, this is the typical section that was given in the textbooks. This is for a louvered window, whereas you have the head of the window frame. So I'm just going to highlight these. That's the head there. And we got the head there of the window frame. We got our glass louvers right here, the louver blades. And how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are about 12 louvers. Over on this one, there's only 1, 2, 3, 4, 5, 6, 7 louvers. But nevertheless, the glass louvers. And then there's the window frame in the background, which are these 2 red lines here. These represent the frame happening in the background behind the louvers. Then there's also a louver operator, the handle, the lever to open or close the louvers. That's here. And then lastly, there's the bottom rail of frame, right? The bottom rail of frame. So you have the head, and then there's the bottom of the window frame, which is the bottom rail of frame. So this is what a typical louvered window will look like when you create a section through it. This is one for a casement window. And this is the section here. This is one for a casement window. It's pretty much the same, except it doesn't have the louvers and it has the same head or frame. It has the bottom rail for the frame down here. So although I didn't label it, these things are still the same as from here. And then there's at the top where you will get the head of the frame, which is the same. So there isn't much difference, except it doesn't have the louvers. Also, it has this middle piece here. And what is this middle piece? When we go back over to here, we realize that that middle piece is the muntin, or is that the meeting rail? That can either be the meeting rail or the muntin. So I think this is the meeting rail here in the middle. All right. Okay. Now this is a typical detail. I found this detail also, and I thought it was worth drawing, which is this detail, which goes through, which says typical vertical section of modified BS window. I think BS means British standards, not what you guys might be thinking, but yeah. So this is it here, where we have, again, let's look at the usual suspects and see what we have here. Usual suspects, you know, the sill, sash frame, the glass, all right. This window has a little more style to it, a little more curves. Yeah, you can look at this and probably looking at it, you would feel as though you're cutting through a window, whereas the other ones, they're very rectilinear. They don't have much shape and character, but nevertheless, it's a window, still a window. So this one here has putty. Now, why would you use putty? Why would we use putty? Putty actually keeps the glass in place there and seals it. So you can use putty, or some people use silicone to just keep the glass fixed there to the timber so that it wouldn't move once it's been installed, right? Yeah, this is the window head here, window head there. Just a very stylistic looking window, very stylish in its design. But these are the parts of the window. And then this is a plastic draft sealer. Again, that means we don't want any wind coming in from the outside because there's a wind gap here. So at this point, it would be sealed off so that no wind can get in there or no moisture, right? And yeah, I mean, these are the typical window details that we would be using in building drawing. If someone were to ask you to create a section through a cross section through a window showing from head to sill, this is what we would do for either a louvered window or a casement window. So now let us go to the last thing that is probably the hardest thing to do. We are going to create an isometric section of this window. And what window am I going to be using? I am going to be using this typical detail right here. I'm going to recreate this now. So to recreate this now, what do I need? I need this information right here. Right? And I need to bring that out here to recreate that. So how are we going to get this done? Well, I'm just going to grab a copy here of this and grab it and then bring it out here. Somewhere out here. And I'm going to remove the hatch. I don't want the hatch. The hatch is going to slow me down. Now, this has been increased, so that means the sizes represent the increase, the scale increase. So the sizes are not the true sizes. So I just need to let you guys know that in the early. So this is, let me just use some rough dimensions to get me around. Okay, that is 857. And again, the reason why I'm not focused on what type of dimensions or if these dimensions are accurate or not, I really don't care. Straight up, I really don't care. The reason being because I'm doing this as a sketch. This is a sketch isometric. Once I sketch it and I label my parts, I can get my marks straight up. It doesn't have to be sizes, but the sizes have to be proportionate. I mean, it can be overly large or it can be very small. So I'm just working with a proportion system, but the measurements really don't matter to me. And then I'll show you why. Just and why am I using these? Oh, right, I have that measurement already. Why am I using these measurements? So as to give you guys at home a general understanding of how this was created so that you guys can actually try to create it if you so desire, right? So now that I have these basic measurements there on what I'm using, anytime I need any more measurements, I'll come back here and I will reference them. I'm going to turn on my polar tracking option here. And I'm going to make sure that it is set to 30, 60, 90, and 120. Okay, good. Cool. Now this allows me to draw in an isometric mode. Easy, very easy. So I just create a line. Okay, I'll put this on too. No, I just got to go off. All right. I'll just carry this up here. You know what? Let me go on to a different layer. Let me go on to the windows and doors layer, alpha line, and I just go up. Cool. Now I want to go on this plane. I just make sure that it says 30 degrees. It's saying 30 degrees there. And I can just draw this across. And I'm going to draw this across 857. So that's the distance. 857. And how much do I carry up? 267. 267. So the first thing is I create a box, right? You know, I always like to start off with a box like that. Right. So at this point down here, this corner is going to be 22. You know what? Let me just bring this closer so that as well I'm referencing this, you guys can see. So just leave it here for now. This part here is 122, so I'm going to come up. I generally do not offset in this menu. I just draw my lines in properly. I generally don't offset. So just leave that there as a starter. Now we need to find, where does this go? How long is that? All right, no problem. Let me go DI from here. No, DIM. So it's to keep the dimension on the screen. Right, from there to there is something like 3. From there to there is 395. So let me just draw a line from here. Oh, 395. Again, it's also in 210 degrees. 210. That's considered one of the angles that you need to use. So let's look at these angles before we go any further. We need to use the 90 degrees. We need to use 30 degrees. 150. We need to know 180 degrees because we'll be using that also. And we'll be using 210, 270, and 330. Those are the angles that we need to know when we're referencing them. So when we just shifting this cursor around, we're looking for key angles to know that we're drawing on the isometric lines, or we're observing isometric angles. And you need to know them, unless you can probably get tricked. You might click at a wrong angle and your whole thing is drawn weird. So this is the line here. Now I need to observe. This goes down here. And what does this line represent? This line represents this point here. No, let me just highlight it. That line there is represented this. I know it's very long, but it will be trimmed eventually. All right, that's one thing. So rest assured that will be trimmed eventually. All right, so that's there. And I need to now represent this distance here, so that I can put in that line. So let's go DIM. That's 214 from this line here. So let's go here, come down here, 214, 214. I found that. Okay, so you can pull down this line here. Yeah. All right. So you can probably get rid of this 214 because we don't need that now. Now that that is in, I don't want to overly confuse this thing. 214. So that's in. That's that line there. And that moves from there to there. And that moves from there to there. All right. Again, saying that this is a sketch. Things don't have to be super accurate. Let's see what's the distance this goes down. This goes down what distance here? 41. This goes down 41. So about roughly about 40. So I'm gonna send this down 40. 40. Cool. Yeah, that's a point there that I need to remember. And this point here, let me see what's this distance from the bottom here. 166. You can also use a circle if you want to. Like I could have come here and open this to 166. Yeah, and that tells me where my line is supposed to be. Right here. 166. Right there. And then I go up my 41. 41. All right. And that's it. So now I can then attach that to there. Yeah. And then I can now attach that there to there. Fairly complex, but let me get rid of these. Let me just trim this now, or fill it. Fill it that. Right? Yeah, starting to take shape now. Move this from there. And this is general shape that it can take. Okay, we got to deal with the back here. Not a problem. Again, this is a sketch, so you can even do something. What angle would this go down at? Let me find one of the, yeah, 230. Let's go fillet. Cool. Nice and easy. Cheap and sweet, you know? Let's keep it moving. And what is these little squares in here? I mean, so I just need to measure one side and I know all the sides. And that's 48. So you're gonna bring in a line here, carry that up, or carry that out, 48. 48. If that is 48, that means it's 24 up. Or it can also be 48. Let's go 48 all the way around. 48. And pull that back there. Cool. Move that so it's centered. Cool. All right. And then we do the same thing here. We need to find this distance. What's the distance from here to right here? And that is 189. So we'll come here and draw 189. Then we go up 48, 48, go across 48, and we go back down 48, right? Cool. So we create that opening. And then the last thing here, this is a drip. This is a drip. Okay, so let's create a box in here now. What size am I going to use? Let's see, 67. So let's go across 67 all the way. 67, 67, and 67. Okay, so this is an isometric box. I'm going to use this to create the isometric circle in between. You always go through the longest diagonals. That's what I've done. So this is a diagonal here at that point, and this is a diagonal. You go through the longest diagonals. Now you cut this in half vertically. Now you cut this in half horizontally, and then you move from, you then go through the short diagonals now, right? From there to there. Now hit C for circle. I'm going this, I'm going through this really quickly because I have a whole tutorial on this thing, how to create an isometric circle. So I don't really feel like I need to go through this at this particular stage. Guys can go back and check that tutorial. It's really well explained, and you can learn a lot more than right here. Right now I'm just moving quickly because the objective is to get this window drawn, right? Or this isometric detail. All right, so hit trim now, and we only wanted a half circle. Oh snap, let's see what happened here. Okay, I'm fairly smart, so I'll get this figured out. All right, so this is my semicircle here that I'm going to now move because it's too high and I want it down here. Cool, good. So now you can remove all this construction. It's not needed anymore. Break these lines. Okay, so that's in there. That's nice little water drip. Those when the water comes off, it drips there, so it goes to the water drip. Now, so this is, so I'm gonna save that. So that's been created. Whew. Now we need to look and see what else we're gonna create. So now that's the sill. We now need to create the sash frame. Yeah. Once I create all these, then I will set them. It'll be very easy once we just finish creating these. So generally, how do I create this now? I am going to use a rectangle to get this. You see, let's create a rectangle first, and then we're gonna then sculpt it. All right. So the first thing is let's go dimension and set these dimensions. What are these dimensions? That's 170 by 206. Right? 170 by 206. So that's the rectangle that I need. 170 by 206. So we're gonna come here. And that means 206 goes up. 206 is my height. And 170, then 206. So I create this like that. First thing, so now I can get rid of these numbers. Don't need these anymore. But then there's an extra height here now, right? Let's see how far this goes at DI from my 170. I gotta go up another 24. All right, no problem. Let's see what's going on here. 46. All right. So let me come here, open up C for circle, 46. Let's see what's this distance here now. DI. Let me see so I can get that. That's 160. So what happens if I come here, C for circle, and I open this to 1, 1, 6 now. Bam. Okay. So we get an intersection there. Nope. I don't like that. That's not what I wanted. So that can't work like that. It's worth a try. It's worth a try, man. This goes at 24, if I can remember. 24. So let me use a different line so that as I'm going out, I know this is 24, 24, and this goes across so like that. Right. So this is where it would probably come into play there. So bam, bam, bam. Okay, cool. So I use the circle to guide me to get around so I can get in that angle, right? Yeah. All right, now let's see what's the depth from here down. Down to that line. That's 86. So I could also have come here and created a circle 86. And then I know that really and truly that goes down to there. All right. Whoa. All right, so I think I got the general shape. General shape in, nice, ready to go. Now, there's another rectangle bit down here. So let us put that in. Let's go DI, measure this distance, 61, and this distance is 24. So 61 and 24. So we go down 61, all right? So we come here at this corner, extend this down, 61. We pull this out on the 24. We carry this back up right there. Let's fill it. Let's max drop this and put everything into this there. Cool. So that's how that looks so far. Not a problem. We gotta find halfway point and put in this hole. How much is this? This square cut out. 24. That's gonna be 24 all around, but it's a square. So let's find the halfway point right here. Bam. Let me put 24. 24. 24. All right. Nice little trick there where I use my Alt key. to line that up into the center after I've created it. All are my control. I think I used control there just now. To line that up into the center. Nice little trick there. So now I've gotten that, and now I need to just put this in place now, right? So it now needs to go into place. So what's the distance from here, di, between here and here? That is about 24, and then on the slope it comes down to 18. All right. So let me just plot a line out here, 24. Let me go down 18. 18? Was that 18? Okay. So let's see how this works out. That means that this point is right here. So that's the point there that I'm looking for. So I grab this, hit move, and slot that into place right here. Oh, so if that goes in, oh boy, we got a little bit of an issue. Not of a problem. I'll just, you know what? I'll put it there, and then I'll just move these. Yeah. Yep, boy. Gotta solve your problems, man. Right. Again, I say don't really mind about these dimensions. Why? Because it's just sketch. So my whole idea is to get this thing sketched so that it looks right. Alright, I think, yeah, that can work out. Yeah, that can work out. Now, let us now continue with the rest of this drawing. Let us scroll back up here and see what else. So we put in the frame, we put in the sash framing, and then we put in the sill. Now we need to put in the glass now, right? The glass goes all the way up, and then at the top we would do the same thing and we will create the head, right? So let's put in the glass now. What's the thickness of the glass? Thickness of the glass is 33. Seal copy, move that 33. Gee, 33 look massive still. Anyway. Let me move this whole thing up here so I don't have to be scrolling around all the time. So just leave it there. Let's have a look at this distance again. Is this really 33? Nah, it worked with 33. So now I need to draw this down here at the top to receive it. I wish I were able to mirror this. Can I mirror this? Let us now set this up and set this up to draw it right here. So I'm going to grab this a little bit here so that I can have something to reference. Look at that. Right. So what do I really need to get this drawn? Can even draw this fairly quickly. So I need a box. That's the first thing. I get a box. I got my box there. And okay, I can even use some reference lines from down here to guide me. So that's my box, and I could put this little extrusion bit here. How much does this go up by? This goes up by 83. So I could see how much this is. Carry this up by 83 also. 83. Yeah. how much does this go down by? This goes down here by a distance of 232. It's right there. Know that? Just carry this down by 232. 232. Okay. It's very close. Let's get rid of this line. And alright, this needs to do this little thing here. This needs to chamfer. I usually just eyeball this. Eyeballing is bad. .307 on the angle. I usually just eyeball this. Eyeballing isn't bad at all. In another world, eyeballing would have been known as sketching. But now we call it eyeballing. But it's not bad. It's not bad. It's 33. 33. 33. Cool. Yeah, I think I got in pretty much, yeah. Where everything needs to go. So this goes up to there. And that goes across to there. And then that goes all the way up to there also, right? Okay, I think I got that in now. Let me just remove this bit that's in here that needs to be trimmed. And now we're going to create the head. The head of this whole organization will be created now. Let's see what's the distance there used to separate them. 33. Okay. So this is the general shape that we're working with. And we pick this up from back here. And we pick this up from, does this go down to there? No. That's a general shape. So let us use some dimensions again. What's that? Cool. So this is 859. This is 301. And let's bring this somewhere over there. And then this one comes down. This is 484. Cool. 484. Just 484. And just leave that there. Let's get that there. That's 254. Just go down here. 254. Cool. And that goes up. And then that's going to go at 33. If you remember. And it's going to go across. Although I'm drawing this right through the whole thing, I still know what I'm doing. So I'm going to move it so it's not just move this up. Hey, look at that. It's all good now. Good. So this, let me measure this distance here. Oh, it's 66, not 33. So let's move that up and carry that up. 66, 66. Then bring that across there, right? Let's get a distance from here. How much does this go across? 248. And then how much do we go up by? 116. So 248 going across. That's 248. And then we go up 116. All right, let's go. That to that to that to that. All right, I think I got it in now. And some hole goes up here. So I'm just going to copy this. Let's put that somewhere. No, it's not directly half. Don't want to make that mistake. 259. 259, right? I'll just leave that there and we're going to copy that hole. CO for copy. Snap there. Done. All right. We getting somewhere. We probably got somewhere and we probably soon about to wrap up this. Okay. So I think I've done the head. I'm just gonna get rid of these so that now I can assemble this now, right? All right. So now I can assemble this. So I got all of my parts here. Then I can get rid of this. The only thing that I might do is reduce the size of the glass in here. Let me just check back 33. Keep always checking that to see if it would change. I don't know why. 33. Okay, cool. All right. Let me put all this into. Cool. No. Let us assemble this. What's the size of the wall that they're using? Usually this is on a 150 wall, but because this is all scaled up, the size here is 874. All right. So let's pull down here. Let's go across 874. Cool. No. I don't want that. That's too large. Because this can't be larger than myself. So not gonna trick me. That's my wall, because I said it. Yep. Nope. I wasn't letting that trick me. Again, no measurements required. Just a nice isometric sketch, and labeling gets you your marks. So you need to know how to do that. All right, so let's move this away from here, put it there. And let's go at the top. At the top, we need to put in this, which yeah, that is 401. What this allows is that you, let me just put this in here. This is a piece of timber which the frame of the window sits on before you actually pour the concrete. The concrete that goes above the window, rectangle of concrete, is called the lintel. That is the lintel which goes above the window. But before we put the lintel in, we actually have a piece of timber which actually lies in between the actual window frame and the lintel. Why is that? That is done so that the concrete itself doesn't touch the window frame, right? The actual window, the factory frame, you actually separate the materials, right? That is why that is done. All right, and then above that we would have our lintel. Right? Lintels also come at the top of doors, above doors, and wall openings too. we have a lintel. So in here would be our lintel, where we will just fill in there with lots of concrete. All right, now my window is set up. All now I have to do is just stretch it and give this a height, and then we can then put in the perspectives so that we can see what happens on the other side. So we've just drawn 1/5 of this whole thing. All right, now so let's give this a random height. Yes, yes, I'm going to stretch STR. Use another tool. Show off to my students. So grab here. Oh, I should have green grabbed it. Okay, lovely. And then I'm going to grab it here and I'm just going to pull it up like yawn and stretch. Good, good, good. Yep. All right, so we just about there. I think that's a good height. Again, all this is sketching. And now I'm going to move this to copy. And I'm going to push this in this direction. Oh, I think 3,153.42 is perfect. So we leave that there. And now we're going to connect these. All right. Doors and windows, get onto that layer and let's connect. Now, I generally draw one thing and copy it around. What do I mean? You'll see. CO, one line, and I just copy this line around to that point, to that point, to that point, there, there, there. Yeah, I generally don't waste that time. And you shouldn't also. Cool. All right, so you need something here at the back. I mean, students, if this is not your style, don't do it. If this is going to confuse you, don't do it. It's not going to confuse me. It might, but I know how to solve this, right? That's the one thing I can tell you. All right, so let's now trim, TR trim, grab the whole thing. Let's see, well, we know you're not going to see this pass here. No, no, no. Not there, not there, not there, not there. You're not going to see that pass any of those. Probably we're not going to even see these here. Yeah, because this line will come over there, right? Yep, so that won't be seen. Let's trim these ones around here so that we make sense of this. Not going to see that. Not going to see that material. That, 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 yeah. And we're not going to see this either. Not going to see that once that pass there. So that means we ain't going to see that. And we ain't going to see this and this either. So these gone, these ones go. Go, go. Probably can move this from there to there. Yep. These ones here. These go. Just trim off this. This one goes. That goes. That one goes. So what we need here is this fillet, this to here. Yeah. Yeah, that's what's needing. And then some things in here need to be trimmed, but we're not gonna see them. Not gonna see that line. No. Get rid of that. Even where you're gonna see things in here. Not really come to think about it. Not gonna see that. Yep. not even gonna see this. Nope. Not this, not this. Just put in the line here. Yep. Let's put in the line here at the top. Yep, and this line here at the bottom. Yep, so this goes, voila. Voila. Not gonna see that, nope. Not gonna see that. Nor that. Nor that. So let's take away the unnecessary. Okay. think this is looking really good. Oh, almost forgot. Control S, save. Save, 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 save. Okay. Finish, finish. Okay, so things back here you're not going to see after this line, right? So I'm not going to see this, 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 or this. Aha. Also not going to see what's happening in here also. So that, go. Right. Starting to look a lot like a window. Uh-huh. Uh-huh. All right, I think I've done a pretty good job. Pretty good job. Of sketching this around the place. I'm trying to show you guys what this will look like. Oh damn, I got some bits and pieces that I didn't put in there, but I am satisfied with this. Okay, it just needs to connect to here. That's the one thing. Let me get rid of two of these. Good. And this is, I'll just move this symbol here. This represents glass. So for copy. Let me just bring that in here. Yeah, put that in there. That's your glass symbol. Now, this is your window, and this is a completed isometric sketch of a window. Now, let me just put these into the proper layers. So this is your outline, which will represent all of your walls. So these represent wall up here, wall, concrete wall, brickwork, etc., etc. Piece of timber. Probably won't see it on that side. It will probably be plastered too. Let me just represent the timber that is here. Let me just put the X to show that we are going through a piece of timber, and I would put that in red. And now I'm going to put in the concrete, which is the lintel. Concrete would go in here. Yeah, just put in any texture and then match drop it, just like that. Now at the bottom, what goes here? Bricks. You use bricks to build up. So this will be block work. I'll label that block work. So I can just probably just label my finish one, and I'll just put this down here. Label that block work, right? BLOCK block work. Block work. Yep, block work. Now this I need to hatch the actual material, and this is a timber. So just gonna hatch in there timber. Hatch the head timber, and that's okay. create a solid fill and match drop the properties from here. And may grab the paint from there, drop it there, plop. Good. Good to go. Now I'm going to hatch the sash frame, which is in here. Solid hatch, just drop any pattern in there, solid, and do the same thing at here. And let me match drop. This is the frame, sash frame. And then in there is glass. I'll probably put the glass in a different color so that's distinguish the glass. I'll probably put it in references, put that in red. Yeah, so you can see this is where the glass goes. Yes, that's your glass. Put it over there, glass, glass. So you're able to see the glass in there now. Now putty. Now we need a nice little hatch in there. I'll probably keep the putty hatch as solid. Just keep it in there, putty. Down here we also need putty hatch. So I would create a line to there, yeah, and a hatch in there, a solid. Cool. Perfect. Perfect. So now let us label here. So I'm going to grab these labels and I'm going to put them in there rather than nice and easy. So let's go through from the top. The top is the lintel, which is a beam above the window to hold the window in place. The beam does not sit directly onto the window material. There's a spacing and there is a frame, that is used. Some of these notes need to go down. They're not in the right position. So let me just adjust them here now. Okay, good. So that's the lintel. Now we move on to the window head. Then we move on to a plastic draft sealer, which is in here to stop the air from coming in. Then there's the putty, which is to keep the window in place, or we can use silicone, but they use putty. This is the glass. This is the glass material that you're actually looking through. It actually allows you to see outside. Sometimes people tint the glass, so as to reduce the amount of sunlight from coming in. Sash framing. Let's move this up here. That's your sash framing here, right? And then this is your sill, your window sill. Right. This is your window sill. And then again, this is the block work of the blocks that you use to build up your wall, which the window will sit in. Again, this is the water drip. This is a water drip right here. I'm going to explain how this works now, because some people might not understand how this water drip. Let me just connect this to here, and let me just bring this down so that it won't be so close there. Yeah. Let me put the word water drip. Water drip. How this works. Okay. So let me just draw it big so that we can understand it now. C for circle. C for circle, and then just put a circle. Okay, come on. All right. So this is what we have here. How does this work? Well, the water is going to be, so let me just continue that. And let us say, yeah. So the water comes off of here now, right? Let me get my arrows and I explain this, and I hope you guys understand. So the water is gonna come here, then come down here, then come there, then it goes here. Now, it's gonna follow this path here, right? But when it gets here, it goes up. And because of this drip, it can't go around, it drops back down. It drops right here. So what this does is this saves the water from actually interacting with your wall and creating that mildew. You usually see a lot of mildew. So let's say if this wall were to continue, this line were to continue, and this were the start of the wall. This will be the start of the wall. Under normal circumstances, you would get this water going, continuing, and no, it will continue here so
on continuing, and then it will come down the side of the wall. We don't want that. That is something that we don't want, right? We don't want that. Nope, nope, nope. Because when it comes down the side of the wall, then you will get you will get you will get the wall to look dirty and you get mildew, and then after a while you have to blast the wall and clean that wall. So a water drip stops that from happening. Essentially, that's what happens. So when the water, now when it's going through a water drip mechanism, it goes here and then the water is channeled right down because it goes up to the R and then it comes down. All right, that's what happens. Or somewhere in here, the water is able to drip off within that curve, right? So it doesn't actually reach the wall. In essence, that is how a water drip works. And you would find these on windows. Yeah, you'll find these on windows or you'll find these on sills, window sills. Okay, so that is the explanation of a water drip, which is down here, which is found at this point here. Okay, so this was quite a long presentation now, but before we close this off, let us just review. The next part of this presentation would be the doors. So again, thanks for watching. I hope you guys understood something and you learned something. What did we do today? We did window types. We went through these window types, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 window types here for you guys to observe. Then we also went through how these windows would look on plan and on elevation. And also when you've drawn these symbols, how you can save these, make these a block, and where can you retrieve your blocks from? You can go up to the insert menu right here, and then you can click on insert and you would be able to find your blocks, right? So that's right here in your insert menu. Now, what else did we do? We looked at parts of a window, and in parts of a window, you're able to see the names of these different parts, like example, the sill, the lug, the meeting rail, the munting, the blind stop, the brick mold, and sash. Those are the different parts of a window. Now, lastly, we looked at some window details. We looked at a section through a louvered window, a casement window, and then a typical window. And from the details, we created an isometric detail of a window. The head, we have the lintel, we have the plastic draft sealer, we have the putty or the sealer, which keeps the window in place so it wouldn't move, and also which stops the moisture from getting into that joint. We have the glass component of the window, the sash framing, the sill, and lastly, the block wall or the block work which the window sits on. Okay, so this brings us to the end of a window presentation. The next presentation that we are going to be looking at, doors in this similar manner. So that brings us to the end of windows. Stay tuned for doors. Now, this has been a long presentation. Please, guys, take this in chunks. Don't all try to digest this at one time. Anyway, please like the channel, subscribe, and do a lot of practicing. Thank you. I am out.